workshop will be based on recommendation systems. And this week we are more like this, and the next week we will be dealing with recommendation systems. So I'll just delve in the details and let you know how this workshop will be presented. So, building recommendation system, there's obviously a lot of things involved in it, and these are influenced by the business needs, like what exactly is the use case, what is the research purpose, what are you trying to solve. So it depends upon a lot of types things, but it can be broadly classified as two types. That is one of them is collaborative filtering, and other being the content based. Now, there are many more variants to it, but these two, you can think of them as the parent systems, and many other variants are derived from this or further classes of these two types. So, talking about collaborative filtering, this is based majorly if you have large training data. So these are majorly like supervised case, and it depends on user inputs, based on inputs from other people, like other items or other people, and not just the user for whom you are recommending. So for example, over you here, you in the diagram you can see that there is a user based and there is an item based. And if you look at the pictures, they would be self-explanatory. Like for example, if you're buying something on Amazon, then if you pick something, for example, a book, then there will be a suggestion showing that customers who bought this item also bought this. So this is based on user similarity. Another thing is item based. Like if you have bought a item, there will be item similarity. Like if you bought this item, then there are items that are similar to the items that you have bought. So that is an item based collaborative filtering. So these are the broad two subtypes of collaborative filtering. And this is what I have explained in this table as well. So the next week of workshop, I will be diving into collaborative filtering. That is more deep into collaborative filtering, and most probably I will be using a deep learning technique for it. But this workshop will be focused primarily on the second type of recommendation systems, and that is the content-based systems. So you can say this is a bit more straightforward type of recommendation system. It can work well on smaller data as well, and it generally recommends based on the user's purchases or history or its profile, or features based on that specific user for whom you are recommending, rather than on different users or different items. So again, if you look at the figure over here, this is the user, and suppose he watches a movie. We will recommend him movies that are similar to the movies that he has already browsed or watched. So this is mainly based on his history or on his taste, depending upon the use case that you are solving. So for this workshop, for this demo, I'll introduce you to a job recommendation system. So there would be different files. I just show you what I'll be going in deep. So if you look at this, for this content-based recommendation, if you look at this flow chart, there are two major parts to it. One would be the jobs data set. So for example, if you are on a LinkedIn website on for your job hunt, so there will be a job data set for the link on the LinkedIn servers. So just consider then some files like over here, this is combined jobs.csv. So, and we'll do some data processing on it. And the other part will be the user data sets. This will contain the details of the user profile. For example, the jobs that he has viewed. So you can see the jobs view, the experience that he has, the and the positions of interest. If he has explicitly generated sub interest that yes, I am interested in so and so positions. So all these features of the user will be merged into a single corpus, a feature, or depending upon the way you want to treat the problem. And then a similarity score will be calculated between the jobs and the user, just to see the ones that are most similar to the user profile. will be given as a recommendation. And before doing the similarity function, obviously there will be some feature engineering that you will do, maybe by TF-IDF, count vectorizer, or different kind of features, like basically trying to um, put the features in a different dimensionality of space. So I'll show you in the notebook how for as an example how we have done that. So yes, now I'll just switch over to the demo. So you can get the data set that is posted on Canvas. It's a zipped file, so you can just this part. It just deals with how I have gathered the data set. So and after that, importing the libraries. So mostly it will be word tokenized top words, and as we proceed further, there are different libraries that we might use. So I'll introduce with the files. So there are four different kinds of files. The first one pertains to the jobs file, and the next three are more related to the users files. So the first data frame that I have read is df jobs, and I'll just switch you to the slide and show you what exactly do I mean. So df jobs is the one that I'm dealing with, the first block over here. That is the jobs data set, and the next three pertains to the users. So I'm just giving you a glimpse of how the data frame looks. And as you can see, there are multiple number of columns over here. So there's a job ID, there's a status, title, position, company name, city. So this is the database of job. Like these are the jobs that are available maybe on a job site, say LinkedIn or Indeed or whatsoever. And obviously I'll choose some relevant columns of it. We won't be using all the features that is mentioned in the CSV. Similarly, I have shown you the glimpse of other three user-based data frames as well. So df underscore exp, that is experience. This is basically this data frame deals with the experience, the past experience the applicant might have had. So for example, over here, the applicant.id is the ID of the applicant, and position.name is the position that he has been on. So account manager, you can see that the same person, he has around three experiences. So first he was a machine operator, then electronics technician, that is the second row, and most recently this one. So this is the position name, this employer name, the city, state, and many other columns pertaining to this. Then there is another views. So this data frame is basically the job roles that the applicant has viewed. So for example, in the applicant ID columns, this the first applicant, he might have viewed a job posting on LinkedIn, and that gets recorded in their servers. And this is the data frame that has been fetched from that part. So for example, this applicant ID has viewed this job ID, and the title of this job ID was this: cashiers and wallets needed. The position is cashiers and wallets. Company is Valley Park. This is the location, and so on. The third data frame is the point of interest. That is a feature supposedly in the job searching websites, say Indeed. There is a feature which allows you to express your interest in the fields that you are interested in, and many of the job applicant portals let you do that. So, for example, the applicant ID, the first applicant has shown interest in the position of security officer, and so on. Like someone has shown in server, some as bartender, and so on. And the next two columns are the timestamps. So this is how I will go through it. First, let's delve into the first data frame, that is the jobs data frame. So the first one that I read, df underscore jobs. So over here, I'll just choose the relevant columns that we will be dealing with. And when you are working on your own on this on this notebook, you can see that why we have chosen so columns. You might come up with some different columns that you think that, okay, this might be useful. So you can come up with that. This is just one way of treating the problem. So over here, I've chosen obviously the job ID, the title, position, company, city, employee type, and the job description. So these are the columns. Then I have checked for null values. And yes, there are null values. Now there are different ways to deal with null values, depending upon the use case, the business problem that you are trying to solve. There are many things that you can do with null values, depending upon the distribution of null values. But since on this demo, I will be focusing more on the, what do you say, the recommendation part, the actual NLP part. So I have just let the null values as be it. But obviously, there are different types of treatment that you can do to it. So I'm not handling the null values per se in specific. Now the tricky part, the main part, that what I am doing with this data frame is that I'm creating a text corpus, because you might remember from the flowchart that at the end we have to compute a similarity score, right? And the similarity score has to be computed on a document. And then we have to do some feature engineering on that document or serve the document as it is. So I am creating that text corpus, that document. And how am I doing that? So just look at this cell. So basically, I'm creating a new column that will represent this text corpus. And this will contain all the words, all the text from the columns position, company, city, employee type, jobs description, and title. So I have simply just concatenated the text of all these columns. So if you see the first row of the data frame, for job ID 111, uh, in the text column, you can see that all the text from these columns have been concatenated. So first is position, so server, then from company, then from city, and so on from employee type. All this gets just concatenated in the text corpus. Now, since I have added all this information in the text corpus, I can like get rid of the columns, right? Like, why to have redundancy in the data frame? Now, this is my choice of treatment that I have done to it. It's up to you how you deal with it. So I just removed rest of the columns, and I've kept the important columns, that is the job ID, that is for reference, because this text pertains to this job ID. So I need to have a primary key in the table, right? So this is the job ID, then the text, and I've kept the title. There is no use of it. You can just let it be. You can remove the title as well. And then I have filled an NA with quotes. That is space, basically space. So yes, this is the main job corpus data frame that has been created. Now over here, I have in this cell, what I am doing is I'm basically cleaning the corpus part. So the text column, which contains all the key information of related to the job, I have to clean that. So there are several things that I'm doing in this. So let's look into it. So for example, there are two functions that I have defined. In the first function, I'm merely checking for whether it's in the stop words. If it's in the stop words, then I'm removing it. And the length of the token should be greater than 2, because I'm just presuming that if it's less than 2, then it's not an important word that should be kept in the corpus. And in the second function is basically the cleaning that I am doing. So you guys can look into it in detail when you are going through the notebook or implementing your own. So I have done lemmatization. I have, for standardization, I have converted all the text to lowercase, and then I have added in a list, then joined. So these are the cleaning steps that I have done, which you guys might be familiar with because you have already done in these steps in the assignments. And then for this column, over here I've just defined the functions. In the next cell, if you see, for the column text, where we are using these functions, I have just applied the function clean text, and the clean text, by the way, calls the first function as well. So just I have applied the function clean text on the entire column. So you can look into the pandas documentation. df.apply means a simple function that should be applied to each row of the column. So this cleaning process is applied to all the rows of the column. And then you can have a look, as you see from the previous part, that the punctuation has been removed, the special symbols have been removed, everything has been turned into lowercase, and if at all, if there are any stop words, those have been removed. Now, since I have generated a cleaner version of the corpus, let's do the actual feature engineering part on it. So uh, you might have guessed it that the feature engineering part would be done on just one of the column, right? And what will it be? It will be the text column. So I'm importing tfidf vectorizer from scikit-learn. So it is scikit-learn.featureextraction.text. From there, I have imported tfidf vectorizer. I have created an object of this, and then I have directly fit transform, not simply fit, but fit and transformed on the text column. So the tfidf underscore job id variable that you are seeing over here contains the feature matrix for each row. So since the so yeah, this is the basically the tfidf feature space for the text column, just the text column, mind you, because that is what is important. And if you look at the shape of this, it is you see that the first element in the shape, the I, is the number of rows. So that is for each row, and the number of columns, that is 50,767, is the number of columns, that is the features. So the 50,000 is the features for each row, and there are total of these many rows, 84k around. So yeah, this would be a sparse matrix, and we have this matrix generated. So I'll just give you a bigger picture by switching back to the slides. So over here, if you see till now what we have done, we have the jobs data set, we did the data cleaning on it, and just right now I just showed you that I have done TF-IDF on it. So we are done with the first part, right? That is the jobs part. Now I will come to the user data sets, that is the 3 data frames that I had shown you. And similarly, we will do the tasks on this as well. So switching back to the notebook. So we'll pick up each data frame one by one. So first, let's say I pick up the DF views. So remember, the DF views was the data frame pertaining to the applicant, that those jobs that the applicant has viewed on the portal. So again, I will pick up the relevant columns, that is the applicant ID, job ID, position, company, city. And I've not shown the intermediate steps in the cell, that I've not shown you the output, because it's the same that we have done for the job corpus. So what I'm doing is I'm creating a new column for this data frame, that is select underscore pos underscore com underscore city. That means select position, company, city, etc. Just given a name to it. And over here, again, I'm just concatenating, adding the info of these columns, that is the job position, the company, and the city. And then again, I have just converted it to string. It is already string, but just to be sure, in the next line, dot map str. And just like in the previous cases, I have applied the clean text function. So if you remember, the clean text function was just for cleaning the corpus. Then just to make sure, again, I have converted everything to lower. This actually is a redundant step, as this has been taken care in the clean text function, but still, just to be sure. And then I have removed the rest of the columns, that is job ID, position, company, city. And why have I done that? Because these information I have already added in the new column that I created. So the new column, select pos com city, I have already added. So let's remove those columns, remove redundancy from the data frame. And when I view the final data frame, this is how is it. The applicant ID along with the select uh, pos com city column. Now, just to give you a bit of intuition, if you are wondering that why I'm doing the steps that I'm just showing you, I'm just taking the key information. So how am I creating the corpus? I'm just taking in fetching in the key information, which could be the job ID, the position. So one corpus I have created for the jobs, and then the similar corpus I'm creating for the users. That is their interests, the job ID, the positions that they are interested, their previous experience, and so on. And then we will do a similarity score in these two corpuses, that is between the jobs and the users. So that is why the steps and the one which would be more similar, those would be returned as a recommendation. So this is one way of doing this, and this is why the steps that I'm showing you, this is how I'm doing it. Okay, now moving on to the next cell. You can see that in this applicant ID, there is like repetition of applicants. So just to like make it more efficient, make the data frame more memory efficient, what I have done is there is one more step that I have taken. Let's group by the applicant ID. So when I am grouping by the applicant ID, what it's doing is that for each row will be just one applicant ID. And what will it do to the corresponding next column? That is the select postcom city. For that column, I'm joining the information for rest of the columns, and I'm doing a reset index. So to look into the details of the code, the pandas code, you can just refer the documentation, or when you are doing it on your own, you will have a get better idea of it. But I'll just show you what I'm doing. So for example, an applicant ID 42 that might have been repeated in the original data frame several times. So over here, there will be no repetitions. So this applicant ID 42, he gets fetched with all the info. So if there were two rows present over here, the two rows have been appended and joined into a single row, because after all, it's the information that we are dealing with. So why not club all the information with a single row rather than having double rows for the same applicant? So that is what I have done. There is no loss of information, since in the code you can see that I have joined the text. And this was for one of the data frame, that is df underscore views. Now the exact same steps have been repeated for experience data set. So df underscore experience, the exact same steps have been done. So this was just one column position name. So this has been taken care of. Then I have sorted by applicant ID. And again, uh, in this cell, I'm just skipping through it because these are the same steps that we have done for the earlier data frame. Sorted the values by applicant ID, filled the NA values, and club multiple applicants into one. Again, the same step we are doing. Like as you can see, there are two applicants, two. In the next over here, you can see in the next cell that there is single applicant and the column has been joined. So volunteer, writer, upload blog, all has been appended into a single row, just to make it more memory efficient and for better training. So this is how I have created the corpus for each user. Then comes the last data frame. I guess it's the last one for the users. That is the position of interest. So here again, the data frame is applicant ID and the position of interest. Again, doing the same steps, grouping by and appending all into one. So there are no redundant applicant IDs. Each row corresponds to one applicant ID, and the position of interest corresponds to the interest of positions that he has shown. Yeah, so this was the last one. Now we have to merge these three users data frame. Remember, I'll switch you back to the flow chart, and we have prepared all the three users data set. Now we will merge it. So what we have done is we have cleaned this before, and now we are merging it instead of merging and cleaning in the same block. So how have I merged it? So first I'm picking up two data frames like df underscore views and df underscore experience, that is exp, and I am doing a join on applicant ID. So that is, now you guys have known the reason why I kept the applicant ID intact in all of the columns, because you need, if you are joining the data frames, you need a key on which you have to join. So if you guys are not familiar with the concept of joins, you can have a look on it into more detail. These are some very interesting topics that you will deal with as a data scientist. And how am I joining it? I'm joining on the key applicant.id, and there is another parameter how. So there are two ways, like how I have chosen as outer. There is one more option of inner. So what inner does is that it will do an intersection of df underscore views and df underscore experience. Why am I choosing outer? So that if there are some applicants that are not present in df underscore views, that is one of the data frame, but they are present in df underscore experience, they will still be added in the resulted data frame, because I don't want to lose on information, uh, of the simple reason, that's why. So why keep an intersection over here? Let's merge on all the users we have, and I name it as a new data frame, that is df underscore view underscore experience, just because of the simple reason that I have merged views and experience. So as you will see, it has two columns: select pos com city and position dot name. All these columns are from both these data frames. So it has been merged into a single data frame. Now I have to merge the third data frame. So I will merge the third data frame, that is the point of interest data frame, with this data frame, that is view underscore experience. So this particular cell deals with that part. So again, I am doing a df underscore poi, that is point of interest, dot merge on df view underscore experience, that is the previous data frame. Again, how on the application dot id key, and how as outer. That is, it is an outer join. And once I have received the final joined data frame, I'm just filling NA with spaces and just showed you how the data frame looks. So you can have a look. It's the applicant ID, position of interest, select postcom city, and position name. Now, what I'm doing is I will just now join all the three columns into a single column. That is creating a final text corpus. So these are the same steps that I have dealt with in the previous cells for previous data frames. So I'm creating a final data frame as df underscore user, created a new column that is known as text, and basically I'm adding the contents of the all the three columns mentioned above, that is select postcom city, position name, and position of interest, and putting them in a new column text. And then I'm removing rest of the columns, and just to be sure, I am applying the clean text function yet again on this um, column. And now I'm showing you how it looks. It's just the applicant ID and the info, that is the entire info, the text corpus. So switching back to the main flow chart, now you can see that we are done with the left hand side of it, that is merging and data cleaning part for the users as well, right? So over here, I'm just selecting a user to be recommended. So for example, I'm just using an applicant ID of 326. And why am I doing this? Just to show you that how will this recommendation system work. So let's recommend jobs to a particular user ID, which is 326. Now that I am dealing with, in this demo, I will be dealing with three types of recommender systems. So let's switch to the first one, that is cosine similarity, really quick. So you have dealt with cosine similarity in your assignments. So what I'm basically doing is I have created a TF-I. So we had done a TF-IDF corpus of the jobs. Now I will do a TF-IDF of the users. So over here I have transformed the uh, user text corpus. So for example, the user Q, which is as the user with 326 ID, I have chosen his text column, that is the corpus, and performed TF-IDF vectorization on it. And then I am doing the cosine similarity between the user part, that is the user feature set, and the TF-IDF of the job ID, that is the entire job corpus. So I have done in this in a map and a lambda function. You can have a look at it in the documentations that how exactly it works. So basically, what I'm doing is I have selected a single user and the feature space of that user, and I'm doing cosine similarity with each of the row of the jobs. So I guess there were some 80,000 80K rows, right? So this will compute a cosine similarity with all of those 80K rows. And over here I have got a output. This is just for my info. So you can see that the length of output is 84K. That is the number of job corpus that was there. And this is the function that in this cell, this is the function that deals with getting the recommendations. So while you're working on the notebook or just going through the notebook, you can have a look at, it's a simple function to just fetch the information of the recommendations. And in the next cell, I'm getting the supposedly say top 10 recommendations. So it will, what this output variable stored was that, this similarity value, it stored all the corpus, but we don't want to see all the 84,000 values, right? I want to see the top 10 values. And how will I choose the top 10? I will choose the top 10 with the highest similarity score. So over here, you can see that I have sorted the output with reverse equal to true. That is in the descending order. So that makes sure that those scores with the highest value are being fetched first. And then I have done colon 10. That means I'm fetching the first 10 values. And then I display the data frame according to it. And you will see that this particular, if you look at this particular user, he was basically Java interested in Java positions and had dealt with Java developer, and that is the reason that you see that the 10 jobs that have been recommended are something pertaining to developer positions and more precise to be Java positions. And you see how it works that the score represents the similarity scores. So Java developer at this title, this corresponds the most to this user, and so on. Similarly, I am dealing now with KNN. So KNN is a very, if you're not familiar with KNN, then you can look into the scikit-learn documentation. You can learn more about the algorithm. But basically, again, what it does is it finds the nearest neighbors. So I will directly jump into the cell and tell you on the fly how it works. So I've chosen 11 just for convenience. I've chosen 11 nearest neighbors, and I have fitted this nearest neighbors on the TF-IDF job ID, that is on the job corpus, and I am feeding to it the user TF-IDF. So what this will do is it will keep a query of user TF-IDF, that is a job feature space for that particular user, and it will match the nearest features that correspond to that user, and it will fetch those nearest features from the TF-IDF underscore job ID feature space. And how does it compute the nearest part? It relies on Euclidean distance. So there are many kinds of distances that you can use. You can look into more detail into the KNN documentation. So by default, it uses a p equal to 2 parameter, which I have not shown over here. So by default, it uses that, and that is a Euclidean distance, and from Euclidean distance it finds the most nearest vectors, and I've done the return distance equal to true. So when I print the variable, you can see that it's actually a tuple of arrays. So the first tuple is the array of distances, and the second tuple is the array of the positions, the job IDs. So again, I am calling the get recommendation function that I had defined earlier, and again it shows me the 10 job recommendations. So as you can see, it is again similar Java developer, entry level developer, and these are the pertaining scores. Over here the scores can be interpreted different. So the higher the score, the more distance it is, because as I've shown you over here, these are the distances. So lower the distance, more similar it is. So over here a higher score of 1 represents that these are the most different jobs. Score of 1 means these are quite far off. So you can see that these jobs are not very much related to the user. So only till job number 8 it is related, and after that you can see that it is retail, sales, hospitality jobs. So the score of KNN is differently interpreted as compared to the scores of uh, cosine similarity. So yes, this is a difference, and this is a different treatment I have. Now the third one being spacey. In the last workshop, you guys would have remember that I had introduced and delved in detail with spacey, and there I had done a document similarity. So basically, this is what I am doing over here. This is just some of the pre-processing parts that I have done. And in this cell, I am calculating the similarity with spacey. So over here, you can see that doc1 dot similarity with doc2. And in the previous cells, I have defined doc1 and doc2. So doc1 is the user and doc2 is the job corpus. So user you can see is a Java developer, and then I have shown the results. You can see that the results of spacey are not at par with those with KNN and cosine similarity. And in real life applications, many times you will have to do a trial and error with several application algorithms and then come in conclusion that which performs the better. So yeah, this was it. These are the three types of uh, algorithms that I have dealt with. You can try with many more different ones. And I rushed for the third part, that is the spacey part in particular, but you can have a look in detail when you are going through the notebook. It's just like for each algorithm, there is a different kind of pre-processing you have to do to make the data in accordance with the model that it is going to be fit in. So that is some steps that you have to take care of.